Hi everyone, Mr. Armitage here, and in this video we're doing another Check Your Understanding. This time, how much of the Earth is covered in water? Okay, from the activity you received on March 19th, and we did the Check Your Understanding on the 20th. Okay, so looking here. Okay, a community activist group in Fresno, California wanted a particular issue to be placed on the ballot of the upcoming election. To make it on the ballot, 600,000 valid signatures were needed. The group turned in their petition with 724,598 signatures. To pass the validity test, okay, 82.8% of the signatures must be valid. Okay. All that's telling us is that we need a certain percentage of the signatures I say we, they need a certain percentage of the signatures that they gathered to be valid. Okay. So that actually has nothing to do with our problem. Okay. I mean, it's context, but we really don't need any of it. Okay. The closest thing that we need is just the 82.8% for perhaps an analysis later. Okay. It's too time consuming to check all of the signatures, so a random sample of signatures are checked. Reasonable. Okay. The individual checking of the signatures needs to be 95% confident that the true proportion of valid signatures are estimated with, at most, a 2% margin of error. Okay, so 2% margin of error, right? That means our margin of error is going to be equal to 0.02. And also being told 95% confident, okay, well, that's how we know that Z star is going to be equal to 1.96. Now, using a conservative estimate for p hat, how large of a sample is needed, right? How, out of these 724,000 signatures, how many do we need to sample to be 95% confident that we have the true proportion with a margin of error of only 2%? Okay. Now remember, conservative estimate for p hat. Okay, your important ideas, right? We went over this. This tells us that the p hat is equal to 0.5, right? 1/2. The most unsure we could be, the most variable something could be is 50-50. Okay, so now we just need to remember our equation for sample size, right? N has to be greater than or equal to p hat times 1 minus p hat divided by, just going to write this out, our margin of error divided by the critical value squared. Okay, so we are dealing with this entire thing here. All right. So if we substitute everything in, we get 0.5 times 1 minus 0.5 divided by, setting that up there, okay, 0.02 divided by 1.96 and squared there. Okay, so there we go. So this will then give us a number. And actually, as it is like this, it gives us exactly 2,401, right? If we just enter it in the calculator exactly as is, as I have written on the screen, right? No finding certain parts of it first or anything like that. Just enter it exactly like this. We get 2,401. So that tells us that n needs to be greater than or equal to 2,401. There we are. That's all we need. Now, in the activist group's previous petition, 85% of the signatures were valid. Using this value as a guess for p hat, so, right, we knew before that 85% were valid on the previous one, so we're going to go ahead and go with that 85% as our p hat value instead. Find the sample size needed. Find the sample size needed for the margin of error of at most 2 percentage points with 95% confidence, right? So the same thing that we had before. And then how does this compare with the required sample size from question 1? Okay, so let's go ahead and we're just going to plug it in, okay? So we get 0.85 times 1 minus 0.85 divided by, now this bottom part effectively just stays the same, 0.02 divided by 1.96 squared. Okay. And when we calculate this, sorry, I don't have this one pre-calculated. Okay, enter it in exactly as is, and we get 1,224.51. Okay. Now remember, when we're talking about sample sizes, right, and sample size for a particular margin of error, we always want to round up. Okay, so n should be greater than or equal to 1,225. Okay, and as we can see, right, because we knew what the confidence interval might be, or sorry, not what the confidence interval might be, we knew what the proportion, p hat, might be, right? We got some extra information about our situation. We need to sample, gosh, almost half as much, half as many signatures, right? Right, this is smaller than the sample size in question 1, right? It's almost half of that sample size, right? 2,400 versus 1,200. Okay, it's a little more than half, but yeah, close enough. Okay. What if the company president demands 99% confidence instead of 95% confidence? Would this require a smaller or larger sample size, assuming everything else remains the same? Okay, so for this one, we could just calculate it, and why not? Okay, we'll calculate it, you'll see what happens, but then I'll explain how. Okay, so assuming everything else remains the same. So we'll just use the information from question 2, okay? Because why not? Okay, so, right, n has to be greater than or equal to 0.85 times 1 minus 0.85 divided by, okay, we keep the margin of error the same, 2. Now, the only thing that changes is our critical value, okay? Because now we're dealing with 99% confidence instead, okay? Remember, this, or perhaps the easiest way to find this, well, one of 2 ways, right? We could use, well, we're going to use inverse norm to find it. Okay? Area, mean is 0. Standard deviation is 1. Okay. The area, 0.99 plus 1 minus 0.99 divided by 2, right? Half of what is left over, we add back, we get our z star. We could also simply remember that because it's symmetric, Okay, we could use negative inverse norm. Okay, and for our area, we just use that, okay, which is going to be 0.005, okay, which will give us 2.576. Sorry, that should be squared there, I believe. Let me double check. Yep, 2.576. There we go. Okay, so now we enter this into our calculator. So we could just bring back what we had before, right? Just redo the entry, change the 2.576, and we get n has to be greater than or equal to 2,116. Okay. Now, when I actually calculated this, I of course got 2,115.1536. Okay. But because we had the decimal, right, we have to round up. So n has to be 2,116. And we see here it increased. Our sample size increased, right? We had a larger sample. Okay. Explain your answer. Well, there's the explanation, right? We plugged it in, all good. Okay, you can stop there. But also, the other explanation is, right, this part here. Right? The idea is the smaller that everything inside the parentheses are, right, the bigger our sample size will be. Okay? Mathematically speaking. So if we have a bigger number in this denominator here, of course, everything inside the parentheses will get smaller, which will end up making the entire number bigger. Okay. The other part to remember, if I may, there we go, okay, is that our margin of error is equal to z star times our standard error, which is p hat, the square root of p hat times 1 minus p hat over n. Okay. Now, if I rework this a little bit, okay, I'm not going to change anything drastic. I'm just going to do this, z star. I'm going to separate out the square roots. Okay, p hat times 1 minus p hat. And by separate out the square roots, okay, divide by the square root of n. There we go. Okay, that's technically over 1. Okay, so as our confidence increases, okay, then we know that this is also going to increase. Okay, right, our critical value will increase. But this, our margin of error, needs to stay the same. Okay, so that is fixed. Okay, so is our proportion, our sample proportion, p hat. That's fixed, so we can't change that. So that leaves the only thing that can change is this, our n. Now, the entire thing here, because z is going up, okay, this entire thing needs to decrease, okay, which it can only do if n also increases, because as n gets bigger, okay, this denominator is going to get bigger, which makes this entire fraction smaller, okay, to compensate for this increased critical value, z star. All right. So that's all for our Check Your Understanding from March 19th. End of the day.